Hi everyone, in this video we're going to go through section 11.2, inferences about two means, where we have dependent samples. Now we've already talked about independent versus dependent samples, so in this section specifically, the individuals selected in one sample to be in one sample are used to determine the individuals in the second sample, and we often hear the word matched pairs design. Here we get to the main procedure slide, all right, and a little bit of my writing that I copied from last semester got a little wonky here, so I'll fix that as we go through and tell you what should actually be highlighted and stuff. But we take our t-distribution, because we're talking about means in this section, so we're using our t-distribution. Remember this formula with the n minus 1 degrees of freedom, x bar minus mu over s over radical n? That comes back with a little twist here. When we test hypotheses with matched pairs, we test the differences of the two samples. Okay, so difference meaning subtract. Okay, so first we'll start out with the requirements. The sample has to be obtained using simple random sampling. They have to be matched pairs. We've already said that. Then this is what should actually be highlighted here, and I'll do it in a different color. The yellow highlighting is wrong. It should be the differences. That is highlighted. The differences are normally distributed with no outliers, or the sample size n is large. And that n is large means, that means that we are greater than or equal to 30. So that greater than or equal to 30 should be referring to that word large right there. Okay, spacing got weird. So again, emphasis being the differences, meaning we subtract the two samples because they are paired together. We subtract the individuals in the sample in the different samples from each other. Okay, so then we determine the null and alternative hypotheses. This mu sub d, that should be a little bit lower. The mean of the differences is the population mean difference of the matched pairs data. And then we get our level of significance. We compute our test statistic, which that should be just a tiny bit lower, but that's okay. Our test statistic, there's our formula. D bar minus 0 over S over subscript D over radical N. Again, weird notation a little bit. First thing, the D bar, there we go. D bar, that is the mean of the differences in the sample. All right, and then S subscript D is the standard deviation, abbreviating that, of the differences in my sample. Okay, n is my sample size, as it always has been. All right, so that's one twist that we throw at you in this section. Setting up, going through the steps and everything for a hypothesis test, that does not change. 5 and 6, critical value, state the conclusion, that's not changing. Just the twist is how we pair the data and subtract and compute the mean and standard deviation from that. Oh, one other thing I wanted to add on here. This 0, right, that is in the formula. It's a little bit weird that it's there. Why do I have to write down 0? Because we're comparing two subpopulations or two samples to each other. If the samples are identical, right, then their differences will be 0. So that represents the samples being identical to each other, when in practicality, in my samples, they're probably not. That's the D bar. Okay, that is equivalent to, in previous sections, x bar minus mu. D bar minus 0 for the hypothesized difference. All right, now let's look at an example where we use this type of hypothesis test. And we have the time it takes in seconds required to catch a falling meter stick for 12 randomly selected students is recorded for both their dominant and their non-dominant hand. Then we were testing if the reaction time for the dominant hand is less than the non-dominant hand. All right, that's what we're testing here. And then we're given the 5% level of significance. Okay, so that's what's going on. And we've got the table to the right that if you wanted to try this out on your own, you could check it in Minitab. I wouldn't type this into your calculator just yet. I'll tell you what you could do in your calculator if you wanted to. But our preliminary work in this problem, and we could wait until a little bit later, but it's probably best to do it now, is to, because this is matched pairs, compute the differences All right, the differences between the dominant and non-dominant hand. And when I say differences, I mean literally subtract them. So I'm going to take 0.177 minus 0.179 and get negative 0.002. And you would just keep going on and subtracting. 0.210 minus 0.202 is 0.008. The next one is 0.022. It's negative 0.22. I'm not going to write down every single one of them. I'm sure that my spacing will get off there. There we go. So there's the first three. I'll write down two more. 0.005 for this next one, 0.005, and negative 0.017. 0.017. There we go. Okay, so there's just the first 5 out of 12. You would go down and subtract each of them. You can do that in Minitab. There's ways to play around with commands in Minitab and have it subtract them all for you. It's not terrible to do it by hand. It's a lot of button pushing, though. But when we have matched pairs, we need the differences between the two samples. Okay, so then this new column, the red column, you can certainly type in your calculator if you want to, but we need, or in Minitab if you have it there, but we need the mean and the standard deviation of the differences. Okay, and I'll tell you what that is. D bar is equal to negative 0.0132, so really small, 0.132, and then the standard deviation, S sub D, of the differences is 0.0164. Before we move on to the next step in the problem, I just want to focus on the numbers here for just a moment, right? Take this first dominant and non-dominant hand, for example. The fact that the difference is negative, okay, think about this for a minute. The difference is negative means that the dominant hand was faster, okay? The next one, the difference was positive, means that the non-dominant hand was faster. Okay, so that's just really analyzing the numbers there. So our mean of the differences being negative means that the dominant hand was faster, but only by a tiny bit. So the question is that statistically significant at the 5% level of significance? That's what we're testing here. Okay, so now let's go back and do the more standard hypothesis test steps that we've been going through. Step 1 is our null and our alternative hypothesis. Okay, so our null hypothesis, here's the notation for this type of problem, is that the mean of the differences is equal to 0. The mean of the differences is equal to 0. And then the alternative hypothesis is that the mean of the differences is less than 0. Okay, less than 0. So again, with the phrasing of this problem, dominant, non-dominant hand, is the reaction time for dominant less than non-dominant? Okay, is the dominant hand faster? Is the reaction time less? Okay, so that's why that is a less than symbol there. We're testing the left tail. There we go. All right, now moving on to step 2, level of significance. All right, so we're going to draw our distribution. We'll label the left tail with a red line, like that. And as a reminder, our level of significance alpha is 0.05, and this is a t-table test. So go to your t-table, look up an alpha of 0.05, and degrees of freedom is 11. Check that on the t-table, and it corresponds to a t sub alpha of negative 1.796. So negative 1.796 is my critical value, my cutoff right there. Okay, that's step 2. Now step 3, we get to the formula where we compute our test statistic. Okay, I'll write down the formula again. T naught is equal to d bar minus 0 over S sub d over radical n. Okay, this shouldn't be terrible to type into my calculator, except for all the decimals. 0.0132 over 0.0164. 4 divided by the square root of 12. Type that into your calculator and it should spit out negative 2.788. I would type this all in one step if I put on the red parentheses that I just added there, or you could do it in 2 steps. You would type in the denominator first and then the numerator divided by second ants. Right? If you're ever confused with the typing into your calculators, just shoot me an email and I can send you a quick little video tutorial of all the calculator button pushing. Okay, but what do we do with that negative 2.788? Where does it fall in my distribution? If I bring it over, it's somewhere over here. It's in the critical region. It's beyond the cutoff. What does that mean? Step 4, you reject the null hypothesis. There is sufficient evidence at the 5% level of significance to conclude that the reaction time for the dominant hand is less than the non-dominant hand. People's good hand is faster, basically, is what that says. Okay? Cool. That is it for this video, just this one big example going through the process. So just make a note of the little minor formula difference, the notation difference, and the fact that we actually compute the differences before moving on to the meat of the hypothesis test. Thank you very much for listening. Have a wonderful day.